I present you Kubilai Kavechi that works for Bloomberg, and he's going to present you load testing on a Python open source project. Kubilai?
Thanks for coming, everyone. My name is Kubilai. I work for Bloomberg in London, and today I'm going to talk about load testing and specifically a Python-based open source tool called Locust. So this is a product we own in Bloomberg. This is like a spreadsheet application specialized for the financial markets. You can have a list of securities you want to follow, like stocks, currencies, and stuff, and you can have real-time market data on the columns. And you can build a market monitor using this application. We also support real-time editing and collaborative editing and sharing. So it's a new cool product, but we are still in the process of releasing it. So it will eventually be released to all of our user base, but we are not there yet. So that's why we usually have meetings to discuss our release. Should we speed up things or should we slow down and focus on some bugs and stuff? So in one of those meetings, we asked this question to ourselves, what is our capacity? And we noticed that we don't have a concrete answer to that, which we should have. Then that's why we decided to invest some time on this and to find out what our capacity is. So how can you find out your system capacity is you can do this by exploring your system qualities. Well, what can be those qualities? It can be capacity in terms of your infrastructure. Is the infrastructure size adequately to your needs? Or does your system respond quickly enough? Or can your application grow to handle feature volumes in terms of scalability? And does your system behave correctly under load, which is a stability concern, right? So how do you assess those quality points? There are a few methods. I will mainly mention performance testing, load testing, and stress testing because they have some overlap, but they're also a bit different from each other, so I just wanted to briefly mention them. In performance testing, you are evaluating the performance of your component against a benchmark. You don't do this, you don't have to create a high load, but instead you tune your application and your testing to establish a benchmark behavior. And your aim is not to find defects in your application by performance testing. Load testing, on the other hand, this time you feed the system with the largest task it can possibly handle. Then you gradually increase the load until things start breaking. So you do this by creating a simulation of virtual users. So you try to replicate your real users with a simulation. And in this case, you are actually your goal is actually find the defects in your application that might be hidden under a regular load, but can be exposed under high load. Those can be memory management issues or buffer overflows and stuff. And you also want to determine the upper limit for all of your components in your system. So your application can handle the load, but maybe your database is hitting its limit or your network is causing problems. So you want to determine the bottleneck in your system. And stress testing, lastly, it's similar in the sense that you still attempt to break the system down, but instead of creating a high load, you try to take the resources away from the system. You can take a few machines down, or you can just turn down a third-party service that you depend on, and you try to observe the behavior of your application after failure. Ideally, you would expect your system to gracefully fail and recover. So I will continue with load testing specifically, but before you invest any of these methods, there are a few points that I think you should consider. First of all, you must have monitoring tools in place, otherwise you won't be able to benefit any of those methods because you won't be able to see the end result basically. And specifically for load testing, you need to identify the usage patterns of your application, because in the simulation you want your simulation to be a representative of your real users, right? So you need to know their workflows and stuff. And you need to define your success criteria in measurable terms. So Like, do you want to handle 1,000 requests a second or a minute, or do you want to be like responding like in less than 50 milliseconds or so? So you need to define that. And you should, that's the last one, but definitely not least, you should always isolate your testing environment. I even have like another slide dedicated to that, because like when I say isolate the testing environment, I mean two things. First, you need to isolate the testing environment from your production environment, so that when you create a load, you don't actually like affect your users. And you should also isolate the clusters that you generate the load from the system that's under test, because like load testing will require a lot of CPU power, and it will use a lot of resources. If you do the testing on the same machine where your service runs, then you will be taking resources away from your service, basically. So how does what's Locust and how does it help with load testing? It's an open source project. It's Python based, and it allows you to define your user behavior in code, which is super powerful. I will come to that. And it's based on coroutines, and it uses an async approach, which makes it very easy to scale and distribute the load. It's also a validated, battle-tested product. We use it in Bloomberg, but I have heard that like the video game Battlefield, they use it before releases. They create like millions of virtual users using Locust to test the game. So Locust provides like two different interfaces to run the tests. First one is a basically command line tool. You can provide the no web option, and you should provide a Locust file. This is where your user behavior is in code. I will show some examples of Locust files. Then you provide the number of users you want to generate, which is 100 in this case, and you need to provide a hash rate. This is the rate which Locust will generate your users, and you can provide an upper limit, 1,000 in this case, like stop testing when you hit 1,000 requests, and it will print the stats to the console. Or you can use this web UI. You can again provide the similar parameters for your testing, and once you hit start swarming, then you will see this nice dashboard. I don't know if you can see, but you can see the request types and request names, and you will see a bunch of statistics about those requests, like number of failures, average response time, maximum response time, and stuff. And there are like a few tabs at the top. In the failures or exceptions tab, you can see a categorization of your failures. Like you can see which requests are failing with which error code. So if you have good error codes, for example, you can notice your database is failing before something else, and so. And that button is to stop the testing, which is important. And this is a very simple Locust file. You need to provide two classes in your Locust file, which one is the one at the bottom, which is the entry point. It's a Locust class. And website task is the task set you want to execute. So in the task set, you need to use the task decorator to define your user's action. In this case, this is a simple website, and it has just two pages, home and profile. And as you can see, task decorator accepts an integer argument, which is basically the weight you can assign to that action. In this case, home page is like more popular than the profile page, so you can assign a higher rate. This is where you can apply your like usage pattern to the code. And Locust also gives you a special hook. It's on start hook. This will be called only once when the user is generated. So if you need to do any like preliminary work, you can like do things like authentication, or if you want to like get random users from somewhere, you can do that so that you don't have to do extra work in the actions itself. And in the Locust class, you provide the task set you just implemented, and you can also define the minimum and maximum wait time. This is the time that Locust is going to wait before sending the next request for that user. So it's either going to going to wait some seconds, between 5 and 15 in this case. But what makes I forgot to mention. So by default, Locust comes with an HTTP client. So if your service communicates in HTTP, you don't have to implement anything more than this. But if you have some like crazy protocol for your service or it doesn't know about HTTP, which was the case for us, you can implement your own custom clients and give it to the Locust. So in this case, we assume that you have a Python client that can communicate with your service. And in this case, we just wrap this send request method with this class. So Locust provides you, like exposes events. So as long as in an action, as long as you fire a failure or a success event, that action will be recorded in the statistics. So in this case, we try to send a request using our custom client. If it fails with an exception, we send a failure event. If it succeeds, we send a success event. For this event, you need to provide some parameters like the request name, request type, response time. So you need to measure the response time by yourself. Or you can also provide the exception type to get a categorization of your errors in the dashboard. So this is how you can write a custom client for Locust, basically. Once you have that, you need to, this is the entry point again, you need to just initialize a custom client and assign it to the client in the Locust class. So you write your tests, and how do you run them? How do you deploy them? We use containers because mainly they are well suited for such tasks, singular tasks, and they're lightweight, they're very easy to deploy, and the most important thing is Locust works in a master and slave fashion. So you can bring up as many slaves as you want to create a higher load. So when you have a like single container for each slave, you can just bring up as many containers as you want, and you can just register them to the master Locust instance, and you will be able to generate a high load. In this case, we use like Docker Compose, and it's just a simple argument to the run command. Like we want to create a Locust instance with like say 20 slaves, and it will just bring up 20 plus 1 containers, and all of them will start swarming. So this is like simple diagram of our architecture. On the left, this is a isolated cluster where our test runs. We have a single master, a bunch of slaves. We also use a Redis instance to share the data across slaves. We pre-populate some data from our database into Redis before running the tests. So we have like some user IDs and some other stuff in the Redis, and slaves can just pick a random user ID from the Redis instance and start sending requests for that user to our alpha cluster, which is like isolated. So our services is running on alpha in this case. So yeah, we did some test runs, and they were quite embarrassing actually. So while testing with a load that we were expecting to have soon, we noticed many drop requests in the test, and it was a single request in our service that was taking too long and blocking others, and the queues in our were filling up pretty quickly, so we were dropping the request. So in order to find out the exact problem in that request, we had to add more instrumentation around our database queries, around our like third-party service calls. So then after more instrumentation, we did the tests again, and we noticed that we actually introduced a regression in a database query very recently. There was like very obvious optimizations, so we just fixed the query and shipped the results, shipped the code, and this is what we get as the results. So this is average response time for that request specifically, and yellow line is our development environment, pink line is our production, and purple is our beta environment. As you can see, the day we fixed the issue on development, it just went down from like 3 seconds to just a few milliseconds. Then you can also you can also see the stage rollout. Like we have a few stages in beta and production, so it took a few days to eventually hit production, and just the fix was on production. Then they all went down to a few milliseconds. So this was like a bit of a success story for us using Locust. And yeah, that's all I have today, and thanks for coming. And if you have any questions, I'll have to answer.
What do you think about using the regular computers, the desktop computers of the people as
to generate a load?
agents? Yeah.
So
Be sure that you restate the question so that
Yeah,
the recording captures it.
So the question is like whether you can use your regular computers to generate the load. This is actually possible, and it's a good solution because your computers are like pretty powerful compared to what you have on the cloud. So you can, yeah, some of the tests I was just running them on my computer. It has like it's 16 cores or something, 8 cores. And yeah, you can use them, and you can, if you can just build a small network of computers and distribute load among them, yeah, that's possible, and it's a good idea, I guess.
Is it possible in Locust to share data between users? I mean, let's say a user creates data and another user with other right. Let's say an admin user, a super user, will use this data. Is this possible in Locust?
So the question is like whether it's possible to share data between like slave instances or any instance of Locust. No, like you can communicate with the master, but that's why we were using Redis. So basically, for example, in our case, when a user like created a resource in our database, it was also inserting the ID of that resource to Redis so that some other user, some other slave can do some operations based on that. So you need to have a like shared instance of something that both can use. Yes.
I'm familiar with JMeter, and can you compare them with Locust?
The question is, am I familiar with JMeter and what's like? Can I compare them? Like I heard about it, I read about it, I haven't used it, but I think it's not possible to provide custom clients like that doesn't communicate in HTTP in JMeter. Maybe you can, I don't know, but and also you cannot provide your user behavior in code, I guess. Can you? Yeah. Okay. Then.
It's like global XML, which you don't
Okay. Yeah. Like we compared some solutions, but I haven't actually tried running a load test with JMeter.
How do you analyze the data, and can you make some statements that if these parameters are not good enough, that you can fail like continuous integration, continuous deployment pipeline?
So the question is how do we analyze the results, and can we like integrate with the CI to fail the build or something? Right now we haven't like completely automated the process, so it's not running on CI. We have to like, it's just a single command, but we have to manually run it. So right now what we are thinking about is like Locust gives you a like CSV file with the response times and stuff. So we want to have that job running on CI on Jenkins, maybe not for every pull request, but like regularly during the day, and just compare the differences like for specific requests, and we can maybe, if it's up like 10%, just fail the job and something like that, you can do that. Yes.
Is Locust able to import curl archive scenarios to fill in automatically the user behavior?
I don't know. So the question is Locust able to import what? Sorry.
Import curl archive.
Curl archive files? No, I haven't seen anything like that, but I don't know, to be honest.
Are there cases where you discovered a problem in production that Locust didn't detect, and did you tell us what you learned from that, if there were?
So the question is if we notice something on production that Locust failed to detect. No, we haven't so far, but maybe they are still there and we haven't noticed them yet. Yes, please, at the back. GI? I can't really hear. So
was the question, have you ever tried Locust in gRPC, like Google RPC?
So instead of using HTTP protocol, the question was whether you can use gRPC protocol. As I can say, we are using like totally custom in-house protocol. So if you have a gRPC client in Python, yes, you can do anything you want.
And is there any support in Locust for REST, higher level REST than just talking HTTP and implementing myself?
So the question is whether there's support in Locust for REST, like at a higher level than HTTP. No, I think it just gives you a bare HTTP client. Then on top of that, maybe you want to have some abstractions. Yeah.
I understand you need the Redis database. Is it? I'm thinking about use case with Locust, where the load injectors are not on the same machine nor even the same network, but on different networks and different clouds to have some kind of swarm of injection. Is it possible to do this given the Redis constraint?
So when you want to like,
Well, restate the question.
yeah, I was going to. So the question is when you want to like create a high load with a bunch of different clusters where they are not in the same network, how do you share data between them basically? So Redis is like just our solution. You can still have a common place, or you can split your data. So we use Redis to prepopulate some data, right? You can split your data like for some specific users, just go to this machine, and some others use that. So they like among clusters, you don't need to communicate. Yep. Yes.
What do you use to represent your test reporting?
So the question is, what do we use to represent our test reporting? So right now we are just like manually skimming through the CSV files, and we have a dashboard with our instrumentation. So we are just going through them and analyzing the results. But when we move to CI, yeah, we need to have an automated process to basically compare the results between different runs.
It's currently not automated. Just
No, they are not automated. So the question is, what's the next step for this project? For us, first we have we have two goals. We want to automate the process definitely to have it on CI, and also we want to test some other backend service that is completely in a different protocol. So we would like to write a client for that, and it's like a pub sub mechanism. So we want to test those as well.
If I understood well, you share data amongst different injector using Redis.
Yes.
And how Locust ensure that a different injector is not going to reuse the same data, so to not repeat the same test many times?
Yeah. So the question is, how do you prevent like using the same data, getting the same data from Redis among different like Locust slaves? We just remove the data. So if one user use the data, it will just remove it from Redis.
You have to do this manually, in the code.
Yeah, it's in the code. But what we do is like if initially you can provide the number of users you want to generate, so we take that number and prepopulate the data according to that. So if it's 1,000 users, we will have 1,000 different user IDs in our Redis instance. So each one can take just one.
Okay, thank you very much.
Thank you. Thanks for coming.